First off, thanks all for joining the talk. We're going to talk about unlocking the power of conda using Pixi, and we're both coming from prefix.dev. So a little bit about us. We, as a company, are trying to solve package management. We've been working on that for 2.5 years now. We're still in the startup phase, but we're growing slightly. We're fully remote and spread around Europe, and we're dedicated to make the conda ecosystem a better ecosystem, like improve it and innovate on it, but we'll talk more about it in these slides. And of course, as every startup does these days, we rewrite everything in Rust. So I'm Ruben. I've been a robotics engineer, and this is my colleague Julian, and he has been in the scientific ecosystem before, and that's how we both got in contact with the conda ecosystem, and that's why we love to improve this ecosystem and work together to make it the best thing that we can. So for those who don't know what conda is a package management ecosystem. The power of conda is the fact that you can have a cross-platform, cross-language experience. So that means that you can install conda packages on both Windows, Linux, and Mac. And you can do that for not just Python, but also any other language. Think C++, think Rust, and we'll have some more examples about that later. And next to that, it uses an environment manager. So the conda packages are not directly installed into your global environment like you would do with APT or Brew or tools like that, but you can actually create these environments that you can activate and deactivate, making sure that you can split your environments into multiple different projects. It already has seen a huge adoption in the scientific ecosystem, especially scientific Python, because it's very useful for mixing Python and other languages together. And currently there is the biggest open source community managed channel, which is called conda-forge. The little logo is there, and there's where all the open source packages are being built into conda packages, and then you can easily use them through the tools that we're building. So you might think, oh, but what if I can just pip install everything, then I'm good. But that doesn't work for everyone. So if you want to use NumPy as a user, you can these days pip install it very easily. So that's what you probably already know. But if you're a developer of NumPy, you might not be fine with just installing it through the pip installation. So you often have to do something like sudo apt installs things, or building the dependencies, or using pacman if you're on Arch. Like, you have a different type of command for every system that you need to work on. And this can be pretty hard on the readmes and the collaboration files if you want to read that for every single operating system, or even distribution within an operating system. And of course, finally, to build NumPy, you just have to use pip again. So you're constantly layering these different types of tools on top of each other and need to make sure that they work together. And testing this can be pretty hard. So NumPy also supports the use of conda, the conda ecosystem, to build an environment for you, and that environment then contains everything that is non-proprietary, and you are allowed to build that environment on your machine, and this command works on every operating system, on every version of Linux. So you don't have to worry about the miscommunication between teams, you don't have to worry about your contributors having problems, and conda can create these environments, but we're actually here to show you Pixi. Pixi can also create these same environments. For instance, in this example, you can just import your environment YAML if you're already used to it, and you can create a Pixi version of these conda environments. So what is Pixi? Pixi is a fast, open source workflow management tool, which also includes the package management through the conda ecosystem, and also the PyPI ecosystem. So that one may be a little bit fast, so let me dive down a little bit in what that means. So what we mean with fast is that we have kind of rebuilt conda in Rust, meaning that we have rewritten basically the same thing, but then started to improve on that. So because the Rust ecosystem allows for has a lot of great tools to work with file system, work with networking, work with caching, all of these things are very much easy to use in these ecosystems and allow us to really build a fast tool that's like built for these low-level, on-the-machine type of tools. Then we build it fully open source, so Pixi and all its libraries are usable for everyone. And the workflow management is something that we built on top of that. So we want you to be able to create these environments, but then you still have to deal with, oh, on Bash you run this command, on PowerShell you run this command, on NuShell you run this command. So Pixi also ships its own task manager, which allows you to, in the simplest form, make an alias, for instance, for Python a file that you need to run, but this can go much further. We'll show a little bit of that later. And Pixi has the workflow management of a project, and that means that we can also add multiple environments to the same project. So you can go a linting environment, you can go a build environment, you can go a user environment, everything into one project. And we'll go back to that later as well. And the best thing about this is all locked down in these log files, so you can reproduce it easily on CI or on your colleague's machine or in your next machine next to you if you have multiple of them. So let's continue. Often we get the question, but what about UV? So first off, we think UV is an awesome tool, and we're not trying to compete with UV in that sense. What we're trying to do is extend what they're already doing great. So Pixi internally depends on UV. They are both Rust projects. They can work together on the system level. So if you do a Pixi installation, we might start pulling some of the dependencies from the conda ecosystem and some of the dependencies from the PyPI ecosystem. Pixi has a smart mapping inside of itself where it will not install NumPy from PyPI if it was already installed through the conda ecosystem, so you'll not have these weird collisions of these two ecosystems trying to play nicely together. Pixi will do that for you. And Pixi, just like UV, uses the workspace model. So if you can see the TOML file on the right, you will see that it can have some dependencies that are PyPI dependencies, and both UV and Pixi can run on this file without any problem. And then you can, of course, do Pixi run or UV run to run these Python scripts. So a Pixi workflow, what does that mean? So if we do a Pixi init, to this simple PyProject.toml, you will add a few mandatory lines that Pixi currently needs, which means, oh, I want to get all my packages from conda-forge, and I want to support, in this case, the Linux platform. Then you can say, oh, let's add cowpy. If I add the --PyPI, I will get it from the PyPI ecosystem, and it will add it into your PyProject.toml in the same place that UV, for instance, would add it. So this experience is very similar. And then if you would add a little file that does something with cowpy, you can run that with Pixi run. This will activate the environment for you and will run the command that you were running. Then you can add tasks. As I said, there's a workflow manager within Pixi, so you can add these, in this case, simple aliases for certain tasks. These tasks will then be run on every platform. So we internally have a shell that will execute these commands. In this case, it's fairly simple, but you can imagine if you start using environment variables or stuff like that, then it's very nice if this works on all platforms without you having to think about what you're actually writing in these commands. Testing it on Linux will have the same experience as testing it on Windows, for instance. And we can go a little bit deeper. So if you want to run these tasks, you can just call Pixi run and then the name of the task, and Pixi will pick up that it was not a command itself, but it was actually a task that you wanted to run. Then we go to the next part. Let me scroll down. You can add something called a feature, and a feature is just a set of things that describe an environment. And that might sound pretty complex, but in this simple example, we just say, okay, the feature PyPI 3.12 will have the Python dependency 3.12, and a similar feature, but with 3.13. So if you then make two different environments with these two different versions of Python, Pixi will solve two separate environments, and we'll also be able to install two different environments. So with this little example, we can run into these environments the same task that we defined before. So if we run Pixi hello in the PyPI 3.12 environment, you see in the simple example that the cowpy will tell you that we're running in that exact version of Python, and the same goes for the other version. And then I would like to give the mic to my colleague.
Thanks, Ruben. So everything that Ruben now presented could have been done by any other modern Python package manager. And that is basically on design. Like the idea is that for very simple use cases, you basically don't pay anything on top of that. You can do any kind of simple Python use case, simple as far as a normal Python package would be able to. But then you can go one step before. Like if we go one slide behind, what you could see here is for these multiple environments, we specified Python, something that most modern Python package managers can do for you too. Like you can use multiple different Python versions. But in our case, it doesn't matter if it's Python, Rust, or any other package. It could be a C++ system library. And that also is reflected in then the resulting log file. So a modern package manager, no matter which ecosystem, typically has a log file, because that allows you to fully reproduce it. But if it's a Python package manager, then the log file will be limited to the Python packages that you have. If you have any kind of system-level dependencies, or in this case Python, that is not necessarily reflected in the log file, which makes your log file basically less reproducible. If you use Pixi and you have the system-level dependencies there too, that will be reflected in the Python in your log file as well. So in this case, we have this very long generated file, and it specifically specifies where is Python coming from, which version does it have. So in this case, it's 3.12.8, which dependencies it has, and also these dependencies, including glibc. Well, not glibc itself, but a glibc requirement, also then specified in your log file. One thing that is also common for package managers which are workspace-based or project-based is the question is, isn't this extremely space inefficient? Like especially conda users, they have like one global environment, which is then used for everything. And this is the big advantage that you also don't have to download and install a lot of things. Like for example, if you need something really heavy like I don't know, QGIS or NumPy or GDAL, then you don't want to have this for every single project individually. The advantage though is that there's a workaround. Well, there's a workaround that we have per default, and for example, PNPM championed that one, which is that we just deduplicate whatever you do. Like if you have a project, a workspace, and one specific environment, which for example uses CowPy of one specific version, use it for a different environment in the same workspace, or even in a different environment in a completely different workspace, as long as it's exactly the same package, it will be deduplicated within your machine. That means there's just no space disadvantage of using like specific project-specific environments as project-specific dependencies. And I think that's one thing that we tried, that Ruben tried at the very beginning, but one point that I really want to drive home is that this works for literally every language. Even technically, it works for literally every language as long as it's supported by the community. Like these are the languages that we found work pretty well. And there is a huge focus on scientific development. So you will find that Python works better than Zig, for example. But technically, there's no limitation to which language you can use. And even if you think you personally are not taking advantage of that because you're a pure Python developer, chances are you're actually doing it at least in some way. Like, I think everyone is using Git here. And Git is a dependency you typically want to install globally, but it's also nice to have it synchronized between all of your developers if you want to make sure that everyone is using the same Git version, for example, because you're depending on certain Git features in your scripts. Then you might want to add it here. Git is written in C, and conda doesn't have any problem with that. And so Pixi also doesn't have any problem with adding it to your dependencies. If you're working with GitHub, it's really convenient to have like a CLI tool which just lets you interact with it without the opening the web browser. And even though it's written in Go, you can add it to your project. And finally, even extremely difficult ones, like on the right you see a QGIS, which is a popular tool in the geospatial space. Even those can just be added as a dependency. Like for example, in the company that I worked before, Prefix, we developed on QGIS because we needed to analyze geospatial data. And we didn't have to install QGIS on each developer's machine. We didn't have to say, you have to install this specific version, so we all use the same one. We just added it to a Pixi workspace. And then it was synchronized for all of us, including when we then developed plugins for that, where it was really important that we all use exactly the same version, or have exactly the same Python version. And in cases where it's not necessary, that is specific to a project, like for example, I mentioned with Git, which you will use for every single tool, and the specific Git version is often not that important, you can just install it globally. So Pixi also supports the use case that you typically would have with your Linux package manager, like apt, or with Homebrew, which you would use on macOS typically. The difference though is if you compare it to, because with pip you can do pip install management system, I think, or management global. But if you do it, people will say, please don't do that. Like this is a terrible idea, especially not with sudo. The reason why pip says that is because it will interfere with your system level dependencies. Like if you use Linux, it might even break your operating system. But even if you use like macOS, it will influence, like the more things you install in this global environment, they will all influence each other. Like you will uninstall one thing and will somehow destroy the other thing, or update one thing, and the other thing now has a different behavior. However, the way we do it, and that's strongly inspired by, for example, how pipx does it, you just install every single tool, in its own environment, and they only expose like what you actually care about. Like if you want to install Git, you install it in its own Git environment. The same for GH, the same for QGIS. What is then exposed is only the git.exe on Windows, for example, or the Git executable, GH executable on the QGIS, whatever is needed to make a graphical user interface work on the operating system. And again, everything is deduplicated, and they will not influence each other. The big difference from pipx, though, is that this works for everything. So while wheels are kind of usable for, like for example, you can install rough, even though it's written in Rust, the more complicated it will become, the less usable it will become. So I, for example, haven't seen a QGIS wheel, and I don't think it will be a thing in the future, at least not in the near future. And finally, one thing that we want to pitch is that one thing that we've now spent most of our energy in is something we call Pixi build, where we see the biggest potential if you have some kind of monorepo, if you have a really big repository, or you just have multiple teams working in different tool chains, different projects, maybe even different languages, then Pixi will be able to manage these source dependencies for you. That means, as an example, you have a C++ package, you have a Python package, and the Python package is depending on your C++ package. Then if you do it a normal way, if you just handle it manually, you want to be able that your changes in the C++ package will actually do this thing that you want on the Python side. You will have to manually recompile C++. You will then run your Python tests and check it that way. With Pixi build, everything is like done through Pixi for you. So if you change one line in C++, you then run your Python tests. Pixi will know that it has to recompile C++, and you will then see that everything is reflected in your Python tests. Like Pixi in general, it's supporting multi-languages, and has a very similar principle as you are used to from PyPI, which is where in PyPI you have Python backends, which produce Python packages. In the Pixi world, you have a Pixi backend, which is producing conda packages. So it's intrinsically useful for any kind of language as well as build systems. And at the moment, we support CMake, Rust, Python, as well as a general one where you can build your build backend yourself. It's also already used. So we, like many other tools, we haven't dared yet to call it a major release. So it's still 0. something. But already major projects are using it. So we are really happy, for example, that Jupyter is nowadays using it and has it in the official instructions. And if you ever heard of Mojo, which is a programming language as well as ecosystem for machine learning and AI, they are now currently moving everything to Pixi, everything to the conda ecosystem, are hosting actually on-premise in our infrastructure. So the whole community organization for Mojo is currently handled with Pixi and our tools. And that was it. As a conclusion, we think that Pixi is a huge advantage over a lot of package managers, especially conda. What we like about it is it's reproducible. It's more reproducible than if you would only use a Python package manager, because it only handles your system libraries, it also handles Python itself. It's fast, it's cross-language, and in the end, our idea is that it's one tool for all of your development needs. Nowadays, even with source dependencies. And finally, it's free and open source. Thank you for your attention, and here you have a couple of QR codes in case you want to connect with us. Thank you.
Thank you so much. We are open for question and answers. If anyone has a question.
I heard there are some plans to align with Python package changes. For instance, I would like to know what you think about PEP 725, where you can define external dependencies, because I guess that would be kind of a real use case for you if you have a real package and then you can install external dependencies. So have you looked into that already?
So I can take that one. I don't have all of the PEPs in my head, but if you're talking about the same one that I now think of, which is authored by Rolf Rommers.
Yeah. I'm not good with names.
Okay.
External dependencies.
Anyways, if we're talking about the same one, then we're definitely monitoring that one closely. Rolf Rommers is actually one person who is very active in the conda ecosystem, and they also see it in the PEP that most of the ideas were inspired by the conda ecosystem. And I think if it actually passes, we will definitely support into that and look into that, how we could best support that.
Anyone? More questions?
Thank you for your talk. Pixi has been a very nice tool for us to use. We've been using it for a while, so it's
Cool.
quite a step up from Conda. So,
Thank you.
one thing that I find a little bit weird when I use Pixi is that by default, any command will try to update the log file. Why is that? Because you always have to provide the no update log file.
Okay. Yeah, so Pixi is designed in a way that Pixi run will always run in a perfect environment, meaning that it was already synced with the manifest and the log file. So there's like 3 states of what Pixi understands, and it's like the manifest, which is a PyProject TOML or a Pixi TOML. Then you have the log file, which is just a result of the solve, and then an actual environment on your machine. And if it finds out that there is an incompatibility between any of these layers, it will try to resolve that and will clean it up. I'm not sure in what case you are experiencing that it tries to relog every time, because that does sound like an issue. But it's the idea that if it finds out very quickly, like, oh, my manifest is in sync with my log file, I'm not going to touch anything.
Yeah, it seems that many tools you have like an explicit locking step, like UV lock, and in Pixi I think I'm missing that, or as far as I remember, at least the version that I was using, and then it like tries to update it automatically.
That is correct. Pixi always tries to keep these 3 things in sync to make sure that like it isn't missed. We maybe have a little bigger opinion on how important the log file is for your setup. We think of it as a free guarantee that you can reproduce your environment, but there is talks about making sure that you don't require a log file in the future.
Yeah, no, I agree that the log file should be. Maybe I'm taking too long. Yeah, but it seems that it's automatically trying to recalculate the lock,
yes.
And I sort of want more the lock to be static, and you create the environments from that instead of even if I have the feeling even if the thing was not changed, even if the PyProject YAML was not changed, it still tries to update the log file.
That indeed sounds like an issue. Feel free
okay.
to try the latest version, and there is actually a Pixi log command now. I could see a future where we make Pixi log the only command that would create the log file. So join our GitHub, join our Discord channel, and we can definitely talk about it.
Thank you. Anyone?
There was a big talk on this conference about the PyLog file and how difficult it was to generate. And now, if I'm using Pixi, I'm using again a non-standard log file. So are there any plans to maybe combine that? I mean, it's probably not possible for you to use the PyLog file for all dependencies, but if I have a lot of wheel dependencies, to at least use that for the wheel dependencies. Do you have any plans to integrate there closer with the Python ecosystem?
Yeah, so the PyLog was recently approved. We haven't yet had time to implement something like that, but I could see a future where we would sync a PyProject TOML with a PyLog instead of the Pixi log file, if that is like the recommended or requested way. But I don't see a reason why we couldn't, because you have the tool section in the log file that we potentially could use. There's no decision on that yet, but could see a future.
Thanks for a great talk. I have one more thing. Most of us we're on Linux or Mac, but most people out there on Windows. And for Windows people, it's a big thing, Conda in general, and this also, because now I can install Git and Pandoc and all those things without going through all these Windows, whatever it is, to get something installed. And that's a big user story. I think that's something you can also maybe stress a bit more, that gives you kind of a cross-platform compiler, including Windows. I think
Okay.
it caused a lot of headache to get it to work in Windows, but once you solve the problem, so the user doesn't have to do this.
Thanks. We'll try that.
Thank you.
Yes. Please.
Thank you for the talk. You mentioned that Pixi also can build conda packages. Is it just calling conda build, or does it offer any additional advantages?
So we have actually our own, like just how we rewrote conda and made Pixi, we did the same with conda build. We call it Rattler build. And that thing, Pixi build, is using Rattler build under the hood.
Okay.
It is.
So we work with a lot of people that are still, very used to working with conda, and one of the big differences, I would say, between conda and Pixi is that the Pixi environments are sort of project scoped or specific, whereas conda, it's sort of like a system environment. And most people are used to, I create a big conda environment and I work with that, and then I work with different projects. How do we convince users? I mean, I'm very much convinced of the Pixi way, but how do we convince others that the Pixi approach is the superior one?
Oh, that's a difficult one. So we struggled with that for a long time. On the one hand, we don't want to be arrogant and say, well, you are wrong and you should use our approach. So we never put it like that. We did it in some way, but not offering the conda way, right? Like, even though we could have provided the conda way, we never did in the past. And at the moment, the team consensus or the team idea is that we kind of do both. So we try to educate the multiple reasons, like it's more reproducible. You don't waste disk space. It's just the same. It's more obvious what is actually happening just for the human load, right? Like, because you can see I have these 4 dependencies, not these 250 that I have globally. Only those 4 dependencies matter for me. Only those 4 I have to take care of. Only those 4 I have to maintain. But we are at the moment also considering, if for whatever reason you cannot work like that, we're currently considering to provide the traditional kind of workflow as well. But we don't have it at the moment.
I think the use case is really scientists who don't want to bother too much. We work at a research institute, and scientists, they don't want to bother too much with installing stuff, setting stuff up. They just want to have an environment that sort of works and then have a bunch of notebooks or whatever to play with that, and so they can survive in their environment for a long time. And they don't want to create an environment for every notebook they create, so to say.
Yeah, I see that. I'm kind of in two minds on that. On the other hand, I want them to produce science which is reproducible. And if they do it like that, it's not.
I agree, but yeah, it's just convenience.
Yeah, I just wanted to comment on that because there is a use case indeed, and there is a use case where people want to have an environment and then have multiple projects with the same dependencies, and then that will be really helpful for those people, I think.
Yeah, so we are aware that there are use cases. We also know that there are a lot of use cases which are actually none. That's why we struggled for such a long time. At the moment, I think both of us would agree that yes, the real use cases that we should support.
Unfortunately, we are running out of time and we cannot take more questions. Thank you so much for being a very nice audience. Thank you.